Hi, welcome. I want to show you how you can calculate the center of gravity of an area, and we start with a beam which is fixed in a wall, and we have a force action on this beam, and we are interested in this stress distribution. In one model we can say this, we have this linear distribution of stress, and the neutral axis is defining the position where the stress is zero, and the neutral axis of a beam is in the center of gravity of the cross-section. So if I have a cross-section looking like this, yes, so then I have to find where's here the center of gravity in this cross-section. We want to find out and to show how we can define the center of gravity of this cross-section. Center of gravity. Yes, and first I have to show you how the geometry of this cross-section is. So I sketch it this way and then give you the dimensions. Let's say from this to this position here it's 1 unit, from here to here there are 3 units. That means from here to here we have 2 units. That means that we have from here to here 5 units, and I will have also in this direction 5 units. That's the definition of this cross section, and I'm interested in the center of gravity of this area. The first thing I will make is we will divide this area into area parts where the center of gravity is known. So I take this first area part, this here, and then I know the cross section area part here has the center of gravity here in the middle. That's the first. And the second part is this here. That's part number 2. And I know in the middle here I have this local center of gravity. And then I have to write down the positions, the coordinates of these local centers of gravity. So it means I have to define a axis system, y, x and y. Yes, and I say here in this x direction here the first local center of gravity, here the distance 0.5, the second here from here to here. That is 3, because of this here have 1 and here have 2 is 3, and the same I make for the y direction. This position is 2.5, and this position here is then 4. So now I've shown the local centers of gravity of these area elements, and now I have to know the area of this element here. This area is 4 times 2, which is 8 square units. Yes, and this area here is 1 times 5, which is 5 units squared. So now we have the position of the local centers of gravity, and we have the area. And now we will calculate the position of this center of gravity of the whole construction here, and I move this part here, this picture in this direction here. Yes, and then I write down how we calculate the center of gravity of this whole area. I say in x direction, xs is xs1 times a1 plus xs2 times a2 divided by a1 plus a2. And then I have to identify what does it mean. This xs1 is this first coordinate of the first center of gravity. That means this is 0.5. a1 is the area, 5 square units. xs2 is the second coordinate, from here to here 3. And a2 is this area, 4 times 2 is 8. Yes, and here we have this 8 and this 5 again. So if I calculate it, I get as a result 2. That is the coordinate of the general center of gravity of the whole area in x direction. So if I will sketch it here in this position here, it's 1, 2 is here in this position. Yes, so that's here is xs, that's 2. Now I have to find the y direction, and I write the same down for the y direction. Let's take a new page here. For the y direction, I write down ys is ys1 times a1 plus ys2 times a2 divided by a1 plus a2. That means here in y direction here 2.5 times 5 plus 4 times 8 divided by 13. If I calculate it, I get as a result, let me see, I will make it 2.5 times 5 plus 4 times 8 divided by 13 is 3.4 units. So it means, if you here look into the picture, the ys is here, from here to here is 2.5, then here that is 3.4, so we are here in this position here. Here we have the center of gravity of the whole area. This position here is 3.4. So if I want to write it in a general way, if we have more than two areas which assemble the whole area, I can write it like this. I can say xs is xs1 times a1 plus xs2 times a2 plus plus xsi times ai divided by a1 plus a2 plus plus ai. Yes, and I is 1, 2, 3 and so on. And in the y direction, ys is ys1 times a1 plus ys2 times a2 plus ysi times ai divided by a1 plus a2 plus ai, and again I is 1, 2, 3 and so on. And then we have a general description of the center of gravity of an area.